Cool. Okay. Hello everyone. My name is CJ Guo, and welcome to TGI Pulsar, and it's episode 10. In this episode, we are going to talk about BookKeeper last at confirm protocol, and that is the protocol that that is the core mechanism that BookKeeper ensure its consistency and making sure it's able to support mission critical service. And as usual, we'll just get started from a week in review. And I'm really excited about this week. And we officially announced that we moved the Post Summit in-person conference to kind of a virtual conference due to the current uh, situation. And we have published we did the call for presentation like a couple months ago, but the whole conference was kind of postponed due to the virus situation. And uh, after a couple months of hard working, and we finally decide to kind of move the whole conference to a virtual conference. And it's going to be a 2 day event that running through from 8:30 a.m. Pacific time, and to like close to 1 p.m. Pacific time every day. And the conference kicks off in on June 17th, and it will continue on 18th. And we have published the full schedule of this conference. You can check it out. We have talks that coming from different uh, companies that who is adopting Pulsar. Really excited about these talks, like talking about why they adopt Pulsar and how they using Pulsar in their production to address their business problems. And also a bunch of the talks are related to ecosystem, like how a Pulsar can be integrating with other systems, and a lot of kind of technical deep dive, and also development oriented talks. So hope we can deliver the first ever Pulsar user conference, and making sure all the Pulsar contributors, committers, users can get together and enjoy a great show. And the sign up is also open, so you can just go to the website and you will fill out a form. And upon you kind of submit the sign up form, you will be receiving a confirmation email um, to confirm that you have signed up. And our event team would follow up with those attendees about instructions how to attend this online conference. And yeah, I'm really excited about this kind of event. It's finally happened, and I hope you also kind of enjoy the schedule. And looking forward to see you online on June 17th and June 18th. The second kind of items I want to talk about is about two release. We finally have 252 is out for voting, and hopefully we are able to close the vote like in the coming Monday. And we also have the next major release 260 is coming. And I think the release manager is kind of clean up bunch of the ongoing items into making sure we are able to include some of the exciting features in 260 release. And please keep an eye on the community and mailing list, and as well as Slack channel. We're going to have this release coming out soon. And on the project development side, I would like to share kind of two new PIP that was coming out this week. The first one, I think it's a very exciting one, is about aiding the producing, consuming, and reading functionality to the existing web server. So the motivation here is HTTP, raise HTTP is a very simple um, API that for people to get started with using HTTP, and also it's available across different languages and different platforms. And we want to kind of reduce the barriers for people to get started. And Pulsar already provide a very comprehensive RESTful endpoint for administrating the whole post clusters, like create tenant, create namespace, create topic, and managing all the namespace policy. And it's making more sense for people to kind of just get started to using HTTP to produce, consume, and reading messages. And that was introduced kind of into a new and kind of HTTP endpoint, not endpoint. It will be still the same web server, but it's just like having a new capability to produce and consume messages. And if you're interested in this topic, definitely check out PIP 64 and give us the comment or feedback in the mailing list. Okay, this is PIP 64. And another one is what we call PIP 65. It's kind of raised by Sanjeev and Jerry from Splunk. The idea is kind of enhance the existing source interface to bring in the capability for Pulsar to support batch source. By default, the source and sync interface that provide in Pulsar IO is actually a streaming source and streaming sync. And by introducing a batch source that kind of enhance the capability of Pulsar IO interface, so it's allow uh, people to develop a source that adapting adapting into a more batch-oriented behavior. Like for example, you might have a batch of files. Then if a bunch of files, you want kind of a source connector that wake up periodically and get the data into Pulsar. Or you might want to schedule some cron job based task that is periodically pulling um, a bunch of the files from an FTP service. So those are kind of the use cases for the batch sources. And if you have similar use case and would like Pulsar to introduce this batch source, definitely check out PIP 65 and join the discussion in the mailing list. So these are kind of the two exciting features that are going to introduce in Pulsar. And the last item in this week in review is we have the upcoming webinar from Nutanix talking about all the lessons that they learned from managing a Pulsar cluster in production for more than a year. So please check out uh, the sign up form, including a bunch of the areas that we are going to cover in this talk. And including like how to do a performance testing and how to optimize a Pulsar cluster and the event sorting pattern with Pulsar, schema usage, and a Flink and Pulsar integration. So definitely it's a very great case study like talk from Nutanix. If you are looking for a real production experience and would like to talk to people in Nutanix, definitely sign up this webinar, and we are looking forward to seeing you online in May 26th. Cool. This is mm, uh, the week in review for this week, and I think we have a lot of exciting like things coming up, and especially with Postal Summit, we are going to have more uh, like exciting features to release announce very soon. So just keep an eye on our different mailing list, email list, Slack, and maybe our Twitter channel. So just really excited about all things happening in Pulsar community. Cool. And so go back to today's topic is since we kind of talking about BookKeeper in general last week, give you kind of a very high level overview about what is BookKeeper and how does Bookie work, and how does Bookie organize all these files. And one of the items that we left in from last episode is we didn't talk much about the client, and the whole consistency and replication are kind of are done in the client level. So in this episode, I'm going to deep dive a bit into the Bookkeeper client, and mainly will be focusing on the last set confirm. So before talking about the client, I would kind of bring up a topic first is talking about the ledger life cycle. We talk a bit about in one of my episodes before, we talk about the life cycle of messages. Then that kind of give you an idea how a message is flowing from client to broker and stored in Bookkeeper, and how it was acknowledged and deleted and garbage collected by bookies. But at the end of the day, uh, Bookkeeper is used for storing all the messages, and for a given partition, it's kind of is divided into many segments, and each segment is stored as a ledger in Bookies. So you have to really understand what is the life cycle of a ledger, and understand the life cycle of a ledger would also helping you understand the life cycle of a master. So I was actually looking into what kind of the slides that we deliver our presentation we deliver back in days, and I actually find a good slides that we did probably a couple years ago, around 2014. We talk a lot about Bookkeeper back in those days, and there was a slides it was actually kind of cover quite a lot about the ledger cycle, or the life cycle of a ledger. Uh, so this is kind of a good overview about how the life cycle of a ledger. So usually, a ledger started by a Bookkeeper client creating a new ledger. And once you create a ledger, you will start writing bunch of the entries. So you keep appending the entries, and once you appending the entries, you would close the ledger. And close the ledger can happen in many ways. Is like one thing is kind of driven by the client. Client say I already append, let's say, 100 megabytes of entries. Then I decide I want to close the ledger and open a new ledger to write my data. So the application can call close ledger to close this ledger. And sometimes it's the client crash, and the ledger will be recovered by another client, and that client would open the ledger and close the ledger. Open ledger is basically recovering the entries that was append in previous owner, um, and making sure it reach a consistent point, and then I close it. And once I close it, the new owner would open a new ledger. And then once you open a new ledger, you keep writing the entries to the new ledger until it reach a certain point, you close the ledger again. So this is a very typical life cycle of a ledger. And what it basically do here is all the entries will leave, will be stored like if the ledger was not deleted. And the entries only be reclaimed when a ledger is deleted. So the deletion of individual entries is the Bookkeeper client doesn't support deleting individual entries. It only support delete individual ledgers. So it delete. You can think about it as a delete data in chunk. So this is kind of a simple overview about the life cycle of a ledger. And to map this to Pulsar, it's actually uh, you will see there's a setting called manage ledger rollover time, manage ledger rollover size. So those are kind of the condition for broker to determine when a broker should load the ledger. And that is a very kind of uh, common behavior about the how people use Bookkeeper for developing their applications, basically just like managing in the ledger level. So once you understanding the whole life cycle, then we can take a look at how exactly the Bookkeeper client work. I was trying to prepare like a slides talking about that, but I just realized I already did a presentation in 2017 in Volt conference. Volt is a conference under Linux Foundation that is more focused on storage, and I think uh, JV from Salesforce and me kind of did a talk about Bookkeeper layer. It's a very kind of very decent kind of presentation about how Bookkeeper work and what is the kind of mechanism behind that. And I'll just use that slides to kind of talk about some of the client working mechanism. And if you're interested about the details, you can also um, check out the link on SlideShare. So I'll just use this presentation to talk a bit about how it works. So it starts from like this inside of Bookkeeper. So as you know, Bookkeeper is basically comprised of three components. Like you have a metadata store. By default, it's Zookeeper. You have a cluster of bookies. Then you have client. And client interacting with bookies over the Ledger API. So that is a very basic idea. And so uh, the client write directly to the bookies using the Ledger API, and the write is in parallel. So there's no such a way. It's not like other replication mechanism that you write to a leader first, and the leader replicate to other followers. In Bookkeeper, is all the replication are done by the client. So a client will write in parallel to all the bookies, and when they write entries to all the bookies, it will store all the store a checksum along with those entries, and the entries would be kind of f-sync to the disk before acknowledge to the client, and all the acknowledge are kind of done in order. So that means uh, an entry can only be acknowledged when all the entries before this entries are already acknowledged. And to acknowledge entry, you have to wait until a column of the bookies respond back to the client. And the column is defined as a column size. So you can configure how many bookies you want to wait for the response. And so as I mentioned before, is a ledger is kind of a sequence of the entries. So from a very high level uh, point of view, that is when you're looking into how bookkeeper sending the entries to bookies, it basically send those entries in sequence, and those entries will be associated with an entry ID, and the entry ID is starting from 0. So in this example is you starting sending an entry starting from 0, 1, 2, 3, 4, and then you keep sending that, and the entry ID would keep increasing. And upon when you're sending those entry out to the bookies, the client would have a pointer tracking that what is the last entry that the client sent to the bookies. What we call it's the last at push, and LAP. Uh, last at push is it's only for tracking like what is the entry ID you have been sent to the bookies, but it's not tracking if I receive the the acknowledgement or response coming back from the bookies. So so you keep sending the entries, and the last at push will keep increasing. And so when you're sending these entries to the bookies, the bookie will respond back. And when they respond back, they would the client would updating the another pointer. The pointer is called last at confirm. Last at confirm means this is the last entry ID. The bookkeeper client is already confirms that this entry has successfully persisted in a column of bookies. And the column here, I'm referring the add column. Uh, last add confirm, all the entries before the last add confirm are already fully persistent, and it's also meet the add column requirement. So in this diagram, you can see here, I have two pointer. That one is last at confirm, the other one is last at push. Sorry. The diagram is wrong. It should be last at push in the blue box. That means entry 0 to 8 to 9 are already confirmed and acknowledged back to the client. And the entry between 10 to 12 are already sent to the bookies. They are outstanding, but the response has not fully coming back yet. That means if at this moment if a reader try to read an entry, uh, you are safely to read 0 to 9, because bookie guarantee like every entries before last set confirm, you can read uh, consistent consistently at any time. So you don't even you crash and coming back to try to read those entries, you're able to get the identical like result. So that is the last at confirm. But any entries that is outstanding, that are not confirmed yet, uh, the reader are not able to read it. So the reader is only able to read the entries are already confirmed. So bookkeeper is basically used last at confirm as a pointer to ensure all the readers can get the consistent view without any trouble. So even you have bookie crash, uh, I'm the reader can still try to read the entries from other bookies and ensure it get a consistent result. So this is last at confirm. But there's a concept that is kind of a, along along with this last at confirm, along with the consistency problem, is last at confirm can making sure all the readers get the consistent view. But if the writer crash and let's say the ownership change, another broker take over the ownership and it try to open a new reader, it will try to append entries to this ledger, then it might be causing inconsistency problem. And how does Bookkeeper address that? Bookkeeper doesn't kind of attempt to reuse a ledger to append the entry again, but what it provides is if a writer crash and ownership change to a new writer, it doesn't reopen the ledger to continue writing to that ledger. What it provides is a mechanism called fencing. What fencing does is basically tell for this given ledger, let's say ledger one, and the new writer taking over the responsibility, it would try to fence ledger one. And by fencing means I will send a fence request to all the bookies that are used for storing the entries of this ledger, and the bookie nodes receive a fence request, it will mark this ledger as not writable. So that means if there's any future writes going into this ledger, they are not able to append any entries. So this ensure at this point, when a writer taking over the ownership, there's no other writers can write the entries to this ledger. So the new writer can safely close this ledger and open a ledger to write. And this would solve the split brain situation when this ownership change happens, when network partition happening. um, a new owner might taking over the writer ownership, but the previous writer is still alive, and those two writers are kind of competing writing to the same ledger. And fencing will prevent this situation happening, and it will ensure no matter how the failure happen, you would always get the consistent view and making sure there's no data corruption, data loss during this failures. So this is a more concrete kind of diagram to explain a bit about fencing. Is in this diagram is basically I have a writer. Actually, no. I have this writer. This the black one is the original writer when it tried to write to bookies. And if a new writer taking over, this is the blue one taking over. And what it do is send all the fencing requests to the bookies to tell bookies that I need to fence this ledger. And once the ledger is fenced, your previous writer, if they try to write append the entry to this ledger, those append would be fenced. So if you have used Bookkeeper before, or if you are kind of using Pulsar, you might notice that you in the broker log, you usually see a ledger was fenced. That typically means there's a topic ownership ownership is transformed to one broker to the other broker due to load balancing. And when a new broker taking over the manager, the ownership of the topic, it will try to close a ledger and fence it. And the previous owner will see the ledger was already fenced. So that is kind of the reason why you would see some of the messages saying a ledger is already fenced. But don't worry about that. It's a normal behavior, and it just means uh, Pulsar is doing the right job to ensure your data is in a consistent state. And so once you have the last set confirmed, uh, the reading a given entry will become very easy. You don't really need to go to a leader to kind of check the to read the consistent data. You can just go to any bookies because you have this last end confirm in place. Each bookie will guarantee you can only read the entries before. Sorry, sorry, read all the entries that before last set confirm. You are not able to read entries that after last set confirm. So that would make read much easier. So when you want to read an entry, you can just go to any bookies to say I want to read this ledger, this entry, and please return the entry to me. And it will also make the uh, failure handling became much easier. For example, read a given entry, we can do a mechanism called speculative read. What it basically do is I will send this read request to any one of the bookies, and if the response doesn't come back with a given timeout, uh, uh, then I would send another request to the second bookie, and I will wait the response coming back from either bookies. And in this way, I can ensure I always get a consistent low latency from this from BookKeeper, because I would not be stacking waiting for one response coming back from one bookie just because that bookie is slow. The network between the client and that bookie is slow. So that is the mechanism to uh, that is the benefits that coming out from the last at confirm protocol. Because you don't need there's no leadership across storage node. You can read from any bookies. And uh, the difference is if you want to read last set, if you want to refresh your last set confirm, because last set confirm is going in, carry on as entries going into different entries. So you might you might need to read last set confirm from a quorum of bookies. Just ensure you're able to cover the add column. So making sure you get the latest and consistent last set confirm. And we kind of combine, BookKeeper also provide a mechanism is combining both read entry and read asset confirm together. That is what we call long pool. So far, long pool is not used by Pulsar yet, but I mentioned that there's a PEEP ongoing in Pulsar is to support read only topic ownership. In order to support topic read-only topic ownership, a wrong poll would definitely help a lot here. Is it will making sure the right owner is able to write the data to the bookies, and the read owner can just telling the ledger and to receive the messages, and that means a long poll will kind of improving the efficiency and also reduce the latency for kind of passing the messages from the uh, writable topic ownership to the read only topic ownership. Okay, so this is kind of a very high level view on the how this bookkeeper last set confirm protocol and financing works, and kind of interesting thing I want to mention here is For a lot of people who hasn't used BookKeeper before, uh, it's a bit difficult to understand a bit how this requires how these entries are append to bookies and how metadata will update it. And I just remember a couple years ago, the author of Raft write a system called Runway. Runway is let me see. Uh, Runway is a kind of system design tools that was kind of used for uh, modeling a kind of a distributed system algorithm for either it combines both specification, model checking, simulation, visualization, and all bunch of the different kind of the aspect around modeling a system together into one system called Runway. And so it basically built a tool to kind of do model checking for Raft, and it also do a very great job for simulating kind of the whole state machine for the Raft algorithm, and also it provide a very nice kind of visualization to understanding a bit about Raft. And I mentioned this is I talked to him around 2014 or 2015, and he actually built a runway model for BookKeeper. And I was this week I was basically checking back to see what kind of materials that we can share about Bookie. And I happen to know, oh, we have a good visualization about this, and we can just use this kind of as a idea to kind of show how exactly BookKeeper works. And so usually it starts from a create a ledger. If you remember the life cycle of a ledger diagram I showed before, is create it start with create a ledger. Uh, I think I need to maybe to yeah. Sorry, I need to refresh because I run a kind of run through a run for that. So as you can see here, I have a zookeeper. I have a client, a bunch of clients. Sorry, I have kind of five booking nodes. So the operation usually start by creating a ledger. So I think this visualization only allow create three ledgers, but it's probably good enough to as a kind of demo in visualization. So just like let's create ledger one. So the client will create ledger one, and so this is it basically you open a writer and create ledger one. It select ABC as a example for ledger one, and then it will write an entry in Zookeeper saying, "Oh, this is ledger one," and the entries for this ledger one are stored in ABC. And as I mentioned, the next step, once you have a writer, you will start writing bunch of the entries. So it's usually just the uh, create an entry. So this is so write the first entry, and the I think it let if I try to write another entry is the you will keep writing entry one. So the last at confirm as you can see here is the last at confirm will update as one because you are kind of already writing the second entry, but the first entry is already acknowledged. And let's try to do another one. So you bump the entries And also it has a good visualization here to help you understand a bit about this. This is ledger one, ledger ID one, and entry is 1, 2, 3. Last set confirm is 2, and we can keep doing ledger 4. And you can see, let's say, at the same time, you might have uh, uh, different writer. In Pulsar case, you might have a different topic that is try to creating a second ledger. So you will see in the ledger I have 2, and this is the state, and I'm able to see this state machine, and it select ADE as the as this ledger, and then I try to append. I need to create a ledger for the second ledger, so it write this ADE. So you will get the you see on the bookie one you have 2 ledger 1 and 2, and on the ledger ADE, so on ledger 4 you will see the same ledger, so the second ledger, and let's keep writing bunch of the entries. And let me just speed this up, and you will see how things are going. So as you can see, you can watch that how the last ad confirm was changed. So if I if I keep sending the entries, your last ad confirm is not changing like in sequence. So if I slow this down, let's say let's use create 3 as an example. If I sending entry one by one, so I'm waiting it come back, then I send another entry again. So you see the last ad confirm is bumping up in by 1. It's just because when I send out the second entry, I already know the entry. And if I send this entry again, then you will see this kind of bump. The last ad confirm is bumping one step by one step. But if you kind of waiting for previous add entry to coming back, then your throughput is not great. And Bookkeeper doesn't design in that way. Is you don't need to kind of wait for the response before sending the next entries. It will still kind of guarantee the consistency. So let's just do quite click the more quickly on create an entries before waiting for the response coming back. You can see kind of the how the ledger was kind of how the last outcome was changed. So right now, in ledger 3, the last X confirm is 2. So let's see and keep watching this green box, because this is the last edge confirm, the last one, the last entry you send out, and in the bookie side, this is the last edge confirm that is keep your track. So in this way is you can, let's see, click ledger 3. Oh, sorry. Oh my, I closed the ledger. I'm not able to send any entries to this ledger anymore. So let's use this as an example. So this, as you can see, I in this I closed this ledger, and I'm not able to append any entries. So I need to open a new ledger, and I think the visualization doesn't do very well, but it probably just like have 3 ledgers, and I'll just use these 2 to append. So this, as you can see, when I'm keep appending, oh, it doesn't go uh, very well. But as you can see, uh, you can replay the whole sequence, and we can see kind of the ledger 2 as an example. But as you can see here, keep watching this ledger 1, And this is open ledger 1. As you can see here, it's updating 0. And as you can see, we are keeping sending this entry out. So the last edge push is keep updating, but your ledger is not updating. Uh, is not updating until you receive the entry. So this should kind of give you an idea about how last act confirm was updated and how we use that to guarantee that the consistency that uh, the the consistency between different readers. So this is kind of the I can reboot some of this ledger, and let me just reboot this so I can replay this a bit to talk a bit about the. I'll just refresh. Talk about the recovery. So let's see. We we close a ledger. So we create a ledger, and we need to get this started. And uh, let's keep writing a bunch of the entries. So as you can see here, this is the visualization to show you when this acknowledgement was actually coming back, and so to give you an idea how the data, the last edge confirm and the last edge push was updated. And this is the at this stage, that's Uh, so normally you can close later once you're done, but if this writer is crashed and some other writer is taking over, what you do is actually I think it doesn't provide a good UI. Technically, I think it would be just a open ledger and to do the venting, but it seems like you can only to do you're not only let me see. So you can only close, but this is just give you an idea. So when you close, it will update the zookeeper. And if you want to replace the whole sequence, then you can watch that, and uh, so you can use this tool to kind of understanding the behavior. Uh, and if you're interested in using this tool to kind of play around the whole bookkeeper consistency model, you can also go to this repo. It's under Salesforce repo. That is called Runway Model Bookkeeper. I think it's a couple years, 4 years ago. But it's very simple. You basically define, you can even looking into the bookkeeper model to understand a bit how exactly the bookkeeper consistency algorithm is working. And it has a very nice JavaScript to kind of visualize that kind of the behavior. If you want to helping improving this tool, I think contribution should be welcome. Uh, okay, so this is more about the runway model, and I want to use that to cover a bit the last conversation about the bookkeeper consistent model. In a lot of time, people would actually thinking, uh, is it a bookkeeper's consistent model or replication model is just coming out from or just start from scratch or just like coming out from a brand new operation? The answer is no. The bookkeeper consistency replication algorithm and consensus model is actually coming from zookeeper's zip protocol, and the log replication part is kind of abstract out of the zookeeper replication. And it's also funny. Most of the log replication algorithm is very similar and very close to Raft. And I actually did a comparison, and actually write a, kind of a paper or a proposal to kind of comparing between the consensus algorithm that in BookKeeper versus the Raft and bunch of other system to give you kind of a high level overview to understanding a bit how the algorithm replication algorithm how was the algorithm coming from is if we take a look at the to do one thing is if you want to take a look at the raft algorithm and zip algorithm is it all starts from a very it kind of influenced by the Paxos algorithm. So the main idea for within Raft in Deb are very similarly. So you have a leader election, and leader election. Once the leader election complete, you would enter a period called in Raft is called term, and in Deb is called epoch. And during this epoch, uh, the leader will start doing the replication to replicating the log entries to different followers. And then once the leader crash or kind of empirical leader election, if a new leader select, it would enter into a new term or new epoch. And during the new term in new epoch, the new leader will keep replicating data to the followers. So this is a sequence how it look like for from a rough consensus algorithm perspective. And if you take a look at how uh, Pulsar, so how bookkeepers manage ledger or the distributed log library perspective is the bookkeeper principle is very similar as Raft or Deb. Is each time you would open the ledger, and once you open the ledger, the writer will keep writing the entries until next until the next ledger was open. The next ledger open can be the current leader close this ledger and open a new ledger to write, or a new owner kind of taking over the ownership, close the previous ledger and open a new ledger. So as you can see here, a ledger is kind of the it's same as an epoch or uh, a term in those existing consensus algorithm. So the consensus guarantee from very high level is it's exactly same as Raft and Deb. And most interestingly, if you want to looking into the replication, so once you have a leader, and the leader will keep writing the data to the followers, and this is the log replication algorithm. If you want to compare these three kind of systems together, you would also see a very interesting um, kind of behavior. In the traditional kind of consensus algorithms, they use term called propose, acknowledge, and commit. So basically, propose is I sending a request to followers. I want to propose one change, and follow acknowledge say accept this change, and then leader will send another request to the follower say commit. And a wrap is kind of abstract this into a more a log replication way is what they call is append entry RPC. So leader would appending the entries to the followers, and the followers would receive the entries. It would then append the entries to my local log, and then send response back to the leader. And the leader would send another entry, append entry RPC to Raft, and this would carry on the last commit index. So basically, in Raft, you don't have a dedicated or separate commit RPC. You just reuse the append entry RPC to carry on the last commit index to the followers, so the followers would use that to receive the newer entries and as well as the last commit index, so they know how to commit the index in its local lock. So this is the Raft kind of the lock replication mechanism. So if you take a look at the this concept and align that with the bookkeeper concept, you will see a very interesting behavior is BookKeeper is also do the very similar thing. It use the add entry as the RPC for appending the entries to the bookies, and bookies would response back to the client saying, "Yeah, I already persistent these entries, so it's it's persistent in my local disk." And the client, the writer, received a response updating the the pointer last at confirm. And then I will try to append another entry again. And when appending this entry, it will carry on the last at confirm. And the last at confirm would use as the commit pointer to tell Bookie this is the last commit entry, and then all the entries before this last commit entry are already confirmed, so you are safely to serve those read requests. So if you compare here is the add entry is exactly same as the append entries in Raft, and the last add confirm is exactly same as the last commit index in Raft. So somehow uh, Bookkeeper, I think Bookkeeper is even coming out a bit earlier than Raft. They are kind of building the log replication mechanism in the exactly same way. So if you know Raft before or read Raft paper before, it might be it might be able to help you understand a bit the Bookkeeper log replication deeply. So this is kind of uh, uh, the kind of the interesting way I have kind of when I kind of step back in thinking about where the log replication algorithm and consensus algorithm coming from. It's all coming from how we simplify Paxos and how we abstract the log replication mechanism into a more efficient in um, way for like highly consistent log storage. So yeah, I think that is the last point I want to add on to the Bookkeeper's the log replication in the last at confirm protocol. So I hope that give you some hint about where you want to look to check out more reference that to get get deeper into the kind of internal of the whole system. So that would be all for the kind of the episode for today. And I also attach bunch of the reference in this note, and including one great blog poster written by Ivan, and Ivan was one of the, I would say, the original developer for Bookkeeper, and he wrote bunch of great blog posts around Bookkeeper and understanding how Bookkeeper work, and also I remember he write a blog post to compare Pulsar and lock device, and that also give a bit deep dive into the difference between replication mechanism and as well as the consistency model. So if you want to check more reference, definitely check out his blog post. And that would be all for today's episode. And thank you everyone for joining my episode. If you like my talk, start subscribe to our YouTube channel, or leave comments uh, for that, and we know uh, the episode is helpful. And if you can think of any areas that we can improve, please also send us the feedback. We want to improve our live stream to ensure everyone can enjoy using, learning, and integrating with Pulsar. And don't forget to sign up for Poster Summit Virtual Conference 2020. And looking forward to see everyone online. And thank you everyone again. Good afternoon, good evening, good night everywhere. And bye bye.